we're asked to find dy dx, so the derivative of y with respect to x. Or in other words, how fast is the variable y changing with respect to the change in x? So we don't know what y is as a function of x. So we need something called implicit differentiation to find this derivative. So take a derivative of this entire equation with respect to x. And the derivative operator gets to go term by term, similar but not the same as the distributive property. Okay. The derivative of negative 5y squared, we'll use the power rule like we normally would. So the 2 comes down and multiplies to make that negative 10y, and the power gets reduced to 1. But then I'm also going to put dy dx on the outside because of the chain rule. Look, we took a derivative of the outermost function. The 2 comes down and multiplies, and it gets reduced by 1. But then what's the derivative of y with respect to x? We don't exactly know. It's not explicitly stated, right? So implicitly we can leave that as dy dx. We don't know what the rate of change of y is with respect to x, but we at least have a symbol for it. Same thing here. The derivative of y, the 1 comes down, multiplies, then it gets reduced by 1. So that's going to be a 1, but then times dy dx. Every time you take a derivative with respect to x of a different variable, we don't know how fast it changes unless they give us the exact formula. So we have to put dy dx. So it's kind of a looser way of putting that. Anytime you take a derivative with respect to x of y, you better have a dy dx come out of it. Or you could just put y prime, right? That's what you might see. That's a little quicker notation. The rate of change with respect to x of a constant is 0. And then this is just normal differentiation. That's power rule on this side. The derivative with respect to x is no funny business there because this is in terms of x. Okay, so we can clean up this side, and I'm going to start using that y prime notation for dy dx. Quicker to write. I'm trying to get y prime by itself. I'm trying to figure out what dy dx is. So I'm going to factor out a y prime in here. And then I'm still trying to find out what dy dx is. So let's divide that negative 10y plus 1 from both sides. So here it is. That's our derivative of y with respect to x. Okay, it still depends on the original y, but that's okay. That happens plenty of times with implicit differentiation.